Okay, so get this. We're taking a deep dive into a full-on cosmic mystery today.
Oh, yeah?
It all starts with something called a stellar stream.
Okay.
And picture this, it's like a river of stars
Really?
flowing through our galaxy, the Milky Way.
Wow.
We're talking about one in particular called GD1, and let me tell you,
Okay.
it's got astronomers scratching their heads.
Really?
We've got a whole stack of research papers here,
Uh-huh.
including a brand new one that just came out,
Interesting.
to try and figure out what is really going on with this stream
Yeah.
and what it might be able to tell us about the universe.
I'm intrigued.
So what's so interesting
Great about it.
about GD1 is that it has these strange features.
Right.
So there's a spur,
Okay.
which is like this extra branch of stars that just shoots off to the side.
Mm.
And then there's a gap where some stars
Oh, yeah.
seem to be missing.
That's weird.
It's super weird. When
Yeah.
you look at an image of GD1, it's this long, thin streak of stars, and then bam!
There's the spur and gap.
Yeah, like a cosmic cookie cutter or something.
It's like someone took a cosmic cookie cutter to it.
Totally.
So before we go any further,
Yeah.
can we just talk about what are stellar streams in the first place?
Oh, yeah, of course.
Like, what are we even looking at here?
Stellar streams are basically leftovers
Okay.
of smaller galaxies or star clusters
Okay.
that got a little too close to the Milky Way.
Uh-huh.
And our galaxy's gravity is so strong
Yeah.
that it just rips them apart
Oh, wow.
and stretches them out over time.
So like spaghettification almost.
It's exactly like spaghettification,
Oh, cool.
but for stars.
Gotcha.
Think of it like pulling on both ends of a string of beads.
Okay. Yeah.
You know how the beads would spread out in a line?
Yeah. Like a pearl necklace.
Exactly.
Okay.
So GD1 used to be something else entirely,
Uh-huh.
and now it's this stretched out stream.
Right. Because of the Milky Way.
Because of our galaxy's gravity.
Yeah. Okay. So this is where things get really interesting, right? Absolutely. This is just the beginning.
Because that spur and gap you were talking about, it's
Yeah,
not
I know.
something you see every day.
Definitely not. It's actually quite unusual.
So did something bump into GD1?
Well, that's what astronomers initially thought.
Okay.
They figured maybe
Like another.
another star cluster got too close and caused some commotion.
Okay.
But here's the thing.
What?
They've searched the entire area around GD1,
Wow.
and they haven't found anything.
Like at all.
Nothing that could have done it.
That's crazy.
It's a real head scratcher.
Okay, so we have a cosmic crime scene.
We do.
We've got this disrupted stellar stream, and we can't find a suspect.
Right.
So could the culprit be something we can't even see?
Well, that's where this new research comes in.
I'm getting goosebumps over here.
It proposes that the disruption
Okay.
might be caused by what's called a dark matter subhalo.
Ooh, dark matter.
Exactly.
Everyone's heard of it.
Yeah, it's kind of a rock star in the astrophysics world.
But what if...
Well, it's this...
How could it be messing with GD1?
Well, it's this weird stuff
Okay.
that makes up most of the mass in the universe.
What?
But here's the thing.
Wait.
It doesn't interact with light
At all.
like normal matter does, so we can't see it directly.
So it's invisible.
It's invisible.
Wow.
We only know it's there because of its gravitational effects.
So it's there, but we just can't see it.
Pretty much, yeah. It's like this invisible hand
That's so crazy.
shaping galaxies and holding them together.
Okay, so it's like pulling the strings
Yeah, you could say that.
behind the scenes.
Behind the scenes.
But how can we even be sure that it's a dark matter subhalo?
Yeah, that's the challenge.
Causing this disruption in GD1.
Right.
And not something else we haven't even thought of yet.
Well, you can't just point a telescope at dark matter and
Right.
say, aha, there it is.
Yeah.
Astronomers are actually using
What are they using?
computer simulations to figure this out.
Oh, so they're basically running like virtual experiments
We've got a...
on the universe.
Exactly.
Okay, that's cool.
So the researchers created a virtual model of the Milky Way,
Okay.
complete with GD1,
Uh-huh.
and then they introduced this super dense clump of dark matter.
This hypothetical subhalo.
Exactly. And they wanted to see what would happen
Yeah.
when this dark matter subhalo passed by GD1 in the simulation.
Okay, so they basically set up a cosmic fender bender in their computer.
That's a great way to put it.
I'm on the edge of my seat.
Well, get this.
Did it line up?
They ran the simulation,
Yeah.
and that dark matter subhalo just zoomed right by GD1.
Uh-huh.
And guess what?
What?
It created the spur and the gap.
No way.
Yes way. It's like the
Okay.
simulation.
Oh my God.
Perfectly recreated the cosmic crime scene that we see in the real universe.
So we have this invisible ghost potentially causing all this trouble in GD1.
It's one way to think about it.
This is blowing my mind.
It's pretty wild, right?
But how does this all connect to our understanding of dark matter?
Ah, good question.
Is there something special about this subhalo idea?
Well, this is where it gets even more intriguing.
Okay.
If this dark matter subhalo really is the culprit,
Mm-hmm.
it actually lends support to a theory
What's the theory?
called self-interacting dark matter, or SIDM for short.
Okay, hold on. Self-interacting dark matter.
I know it sounds a bit strange.
What's that all about?
So you see the usual model of dark matter,
Uh-huh.
which we call cold dark matter.
Okay.
It says that dark matter particles,
Yeah.
they just kind of zoom around,
Uh-huh.
basically ignoring each other.
Okay.
They don't interact at all.
Really?
Like they're these lonely wanderers,
Wow.
only influenced by gravity.
Okay.
But SIDM,
Yeah.
it suggests something different.
What's that?
It suggests that these dark matter particles,
Mm-hmm.
they can actually bump into each other,
What?
like tiny little billiard balls on a cosmic pool table.
So instead of just being these lonely wanderers,
All right.
these dark matter particles can actually like have a little chat with each other.
That's a fun way to think about it, yeah.
I like that.
And even though those interactions are weak,
Okay.
they can have a huge impact on how dark matter clumps together, especially on smaller scales, like these subhalos.
Okay.
It's like a cosmic traffic jam.
I love that.
Instead of just zipping around freely,
Right.
they're bumping into each other, creating these dense pockets.
Oh, okay.
And one of these cosmic traffic jams
Yeah.
might have caused the disruption we see in GD1.
So we might have stumbled onto a whole new way of thinking about dark matter.
It's possible.
This is huge.
It's pretty exciting stuff.
This could change our understanding of how galaxies form and evolve, right?
It could, but
No.
it's important to remember that this is just one study,
Right.
and more observations
Oh.
of GD1 and other stellar streams are needed
Okay.
to see if this pattern holds up.
We don't want to jump to conclusions too quickly,
Exactly.
but still the implications of this are mind-blowing.
It is mind-blowing.
It's like we're peering into this hidden world of interactions that we never even knew existed.
I know. It's like a whole new layer of the universe.
This is just the beginning of our deep dive into GD1, and I'm already hooked.
Oh, there's so much more to come.
Stay tuned, folks, because we're about to go even deeper into this mystery.
Get ready to be amazed.
I can't wait.
All right, let's do it.
Let's go.
So we left off talking about how this dark matter subhalo
Yeah.
might be the culprit behind the weirdness in GD1
Uh-huh.
and potentially lending some weight to the idea of self-interacting dark matter.
Right, SIDM.
As DM, exactly.
Okay, so can we just break this down a bit more?
Of course.
Like, what's the traditional view of dark matter?
Okay.
And how does this SIDM thing shake things up?
All right, so the standard model,
Yeah.
what we call cold dark matter,
Uh-huh.
assumes that dark matter particles are like super inert.
Inert. Yeah.
They don't interact with light
Okay.
or normal matter.
Uh-huh.
And most importantly, they don't even interact with each other much.
So they're just like these loner particles just doing their own thing.
Pretty much, yeah, passing through each other like ghosts,
Ghosts.
only influenced by gravity.
Wow. So they're in their own little world,
Yeah, you could say that.
completely oblivious to everything else happening around them.
Exactly.
Okay.
And in this cold dark matter model, these particles, they move relatively slowly.
Hence the cold part.
Exactly, hence the cold part.
Okay.
And this model has been super successful
At doing what?
at explaining how large-scale structures like galaxies
Uh-huh.
and clusters of galaxies formed
Right.
over billions of years.
So for a long time, it seemed like cold dark matter was like the answer.
Yeah, it was like the holy grail.
The dark matter puzzle.
It fits so much of the data.
But
Wow.
now
Wow.
we have this ITM idea challenging that view.
Right? CDM suggests that dark matter particles can actually interact with each other.
Okay, wait. So they're not completely ignoring each other?
Not necessarily, no.
What do you mean?
Well, these interactions, they're much weaker than the forces we see in normal matter.
Oh, okay.
It's like they have a secret language.
They can talk to each other.
Kind of, yeah, a way of communicating and influencing each other.
And we're only just figuring this out.
Exactly, we're just starting to understand this language.
And this secret language
Yeah.
could be the key to explaining why dark matter clumps together in these dense subhalos.
That's the idea.
Like the one that might be messing with GD1.
Precisely.
Okay, so instead of just zooming around freely,
Right.
like in the cold, dark matter model,
Uh-huh.
they're bumping into each other in subhalo
Right.
and creating these dense
It's
pockets.
like I said before,
Yeah.
a cosmic traffic jam.
So one of these cosmic traffic jams could have caused the disruption.
It's possible.
Yeah,
We see in GD1.
it's a very compelling hypothesis.
It's like we're solving a mystery
Uh-huh.
with an invisible clue.
That's a great way to put it.
Okay, so if this SIDM theory is right,
Yeah.
what does it mean for our understanding of the universe? Well, it could have some pretty big implications.
Like what?
If dark matter is more complex and interactive
Than we thought.
Uh-huh. It could change our understanding of how galaxies form and evolve,
Okay.
how they cluster together,
Uh-huh.
even how the universe itself came to be the way it is.
This is huge.
It's definitely a big deal.
So this one strange stellar stream, GD1,
Right.
might be giving us clues about the fundamental nature
Exactly.
of dark matter and its role in shaping the entire universe.
That's the beauty of science sometimes.
Wow.
These unexpected discoveries can lead to these really profound insights.
But you mentioned earlier that we need more observations.
We do.
To confirm this SIDM theory.
Right. It's still early days.
What kind of observations?
Well, astronomers are looking for more examples of stellar streams
Okay.
with similar disruptions.
You mean like
Those telltale signs of a dark matter subhalo encounter.
the spur and gap?
Exactly.
Okay.
If we find enough of these streams with similar features,
It'll strengthen the case for SIDM.
so it's all about finding patterns.
In a way,
Looking for those cosmic fingerprints that point toward
interacting dark matter.
SIDM. Exactly.
Okay, this is blowing my mind.
It's pretty amazing stuff.
So this bigger picture
Yeah.
might just reveal a universe
Right.
that's far more complex and fascinating
Absolutely.
than we ever imagined.
And who knows what else is out there waiting to be discovered.
Okay, you've officially blown my mind.
I'm glad I could contribute to a mind-blowing experience.
So we've got this cosmic mystery,
Right.
a potential solution involving self-interacting dark matter,
Mhm.
and the possibility that we're on the verge of uncovering even more secrets about the universe.
It's an exciting time to be studying astrophysics.
It really is.
And the universe is full of surprises.
Always.
Just when we think we've got things figured out,
Yeah.
it throws us a curveball like GD1.
Right.
And it forces us to rethink everything.
And push the boundaries of our knowledge. Speaking of surprises,
Yeah.
you mentioned that SIDM could have implications for how galaxies form and evolve.
Right.
Can you tell me more about that?
Sure. So remember how we talked about cold dark matter being really good at explaining large-scale structures?
Yeah.
Well, there are some smaller scale puzzles
Okay.
that cold dark matter struggles with.
Like what kind of puzzles?
For example, cold dark matter predicts that galaxies should have this really dense concentration of dark matter
Okay.
right at their centers.
It's the very center?
Yeah, right at the core.
Okay.
But when astronomers observe galaxies,
Yeah.
they often find that the dark matter distribution is smoother.
So it's like more spread out.
Yeah, more spread out than it should be.
According to the cold dark matter model.
Exactly.
Yeah.
And this is where SIDM might be able to help.
Okay. How?
Well, if dark matter particles can interact with each other, those interactions could smooth out the distribution
Okay.
of dark matter in galaxies.
Making it less concentrated at the center.
Exactly.
So SIDM could potentially solve some of these smaller scale mysteries
It's possible.
that have been bugging astronomers.
Of quite a while.
This is incredible.
It's fascinating stuff.
So to recap, we've got this stellar stream GD1
Right.
that's acting strangely.
Mm-hmm.
And a new study suggests that a clump of self-interacting dark matter might be the culprit.
That's the gist of it, yeah.
And this finding
Right.
could have profound implications for how dark matter behaves, how galaxies form, and potentially even how the universe itself evolved.
It's a pretty big deal.
Now we're getting to the heart of the matter.
Okay.
What does this all mean for us?
That's the big question, isn't it?
For our place in the cosmos?
It really makes you think.
Stay tuned as we explore the bigger implications of this discovery in our final segment.
It's going to be a good one.
Okay, so we've spent all this time talking about GD1.
Right, this mysterious stellar stream.
With the spur and the gap.
Yeah, those weird features.
And this whole idea of self-interacting dark matter.
It's a game changer.
It really is, but what does it all mean for us?
That's the big question, isn't it?
What's the takeaway here?
I think the biggest takeaway is that we keep discovering the universe is way more complex than we ever thought possible.
It's humbling.
It really is. And,
Right.
here we are looking at this seemingly insignificant stream of stars.
GD1.
Yeah. And it's giving us clues about dark matter.
This invisible force that we can't even see.
Right. But it's out there.
And it makes up most of the universe's mass.
Which is mind-blowing when you think about it.
It's like looking at a tiny piece of a giant puzzle.
Exactly.
And suddenly that piece is giving us a whole new picture of how everything fits together.
I love that analogy.
It's like we're cosmic detectives.
I like that, too.
Following the clues.
Yeah.
Wherever they lead us.
And sometimes they lead us to the most unexpected places.
And this whole story about GD1, it's really a story about the power of science.
Absolutely.
It's like science is this incredible tool that helps us unravel the mysteries of the universe.
And it pushes the boundaries of our knowledge.
So even though we've learned so much about the universe,
we've come a long way.
There's still so much more out there.
Oh, yeah. We're just getting started.
Who knows what other strange and wonderful things are waiting to be found.
Right. Like maybe there are even more exotic forms of matter and energy
that we haven't even dreamed of yet.
It's definitely possible. The universe is full of surprises.
Okay, well, on that note, I think it's time to wrap up.
Yeah.
Our deep dive into GD1.
It's been a wild ride.
We started with this bizarre stream of stars.
Yeah, a seemingly simple observation.
And we ended up exploring the deepest mysteries of the universe.
That's the beauty of science.
It's been mind-blowing.
I'm glad you enjoyed it.
And who knows, maybe one of our listeners will be the next scientist to make a groundbreaking discovery.
It could happen.
About dark matter or some other crazy cosmic thing.
I hope so.
Keep looking up, everyone.
Yes. Keep those eyes on the sky.
Keep asking questions.
Curiosity is key.
And never stop exploring.
The universe is waiting.
Thanks for joining us on this deep dive.
It's been a pleasure.
And until next time, keep wondering.